So let's look at part two. Did you guys already start it, or we want to do that together?
I went through it a little bit, but
Okay. I
this
did too.
chapter's a little more complicated than the others about the bivariate data.
Yeah, because of all the requirements.
Mm-hmm.
Yeah, it was a little bit more. Let's see. There we go. Okay. So, yeah, no, I know. I didn't really like having to do all of the requirements to check it.
Yeah.
All right. Okay. Okay, so on part one, you're just kind of writing down the lesson notes. Are we okay there? Any questions on that?
I'm good on part one, yeah.
Okay. So on part two, we've got our 5 requirements. It looks like a linear relationship when you scatter plot it, right?
Uh-huh.
Okay. And then I don't know why he's doing the QQ plot first and the residual part second. It seems like that's out of order, but I guess it doesn't matter. Yeah. So I plotted the residuals with the x values first and did that scatter plot, like they said, and it was kind of all over the place, so that was random, like they want it to be.
Yeah.
Okay. Did anybody have problem? You didn't have any problem with that? And then the QQ plot. So did you do that part, Annie, or did you have any trouble with that?
No, I just had to remember where to find the QQ plot. I totally forgot which spreadsheet it was, so it took me a little bit to find that, but
Yeah. So if you just go to the quantitative descriptive.
yeah.
Yeah. So then, yeah, go to the QQ plot and just plug in the residuals there and make sure that they're in ascending order. That's the part I always forget. Then it does look like pretty much like a line.
Yeah.
So those 3 are done, and then with the D and E, I mean, there's really no way for us to check that. We just have to assume that whoever did it right.
Yeah.
So.
Okay.
And number 2, test if there is a linear relationship between head length and body length. So the null and alternative hypothesis. The null hypothesis is that the slope is 0, and the alternative is that it does not equal 0. That didn't make a lot of sense to me, I'll be honest with you. I honestly thought they would look at R. I don't know why we're looking at slope.
Yeah, I have no idea why. I just got that from the lesson, but I'm not sure.
Yeah, exactly. That's what I did too. Yeah, so I would love to, just ask somebody, why are we looking at that instead of like, if R is above 0.6 or below negative 0.6, then we consider that, but I don't know. But I haven't really thought about it that hard, but why would the slope be 0 if the scatter, if it doesn't fall along a linear progression?
Yeah.
Anybody? I mean, I guess if it scatters everywhere, right, then you would have a horizontal line. But
slope.
Yeah. Okay. All right. So with the alpha be 0.05, the t statistic. Anybody have any trouble with where to find the t statistic and the p-value and all that kind of stuff? We okay there?
Yeah. It's all on the.
Okay. All right. So then we have sufficient evidence to suggest that there is a linear relationship because the p-value is so small. And then the 95% confidence interval for the true slope of the regression line, 6.704 to 8.096. You just have to make sure you're looking at the correct confidence interval because they have like 4 of them on that sheet. But they said for slope, so you look along slope. So
I kind of just thought of it as the null hypothesis has to do with B1, so that's kind of where
yeah.
I had to focus because there's so much information on this one.
Yeah. Okay. Okay, so should we go to the quiz?
Yep, let's do it.
Okay. we on? Are we on week 12?
Yep.
Wow.
This is our last new lesson. Next one is just preparing for the exam.
Wow.
Shoot.
All right, was this to open anything up? We don't have to open anything up for this quiz?
Yeah, they're using the math self-efficacy, the estuarine crocodiles, and the gharial crocodiles.
But that's all on the quiz. You don't open it before?
Yeah.
Okay. So you've already done this, haven't you? You've already started, haven't you?
I just
We're behind.
opened it to see. I haven't filled it all out.
All right, the true linear regression equation is y equals b sub o plus b sub 1x, where b sub o and b sub 1 are unknown. What are the null and alternative hypotheses for b sub 1? That b sub 1 equals 0 and that it does not equal 0, right?
Yeah.
Okay. So that one for me is on the third. I don't know if it's the same. Okay. A residual is what is left over after doing simple linear regression. The observed value y and the value predicted by the regression line. Yes.
Oh, yeah.
So it's B, because I was really unsure on this. I didn't see where in the lesson it said what the residual actually is.
Yeah, that's what the residual is. So you know how it'll predict a value for y, Annie, but that's not usually what we actually get when we plug in that x value?
Yeah.
And so that's what the residual is the difference between those two, between the observed value and the actual predicted value.
Okay.
Okay, a plot of residuals supports using linear regression when plot of residuals. So you see mega function residuals that normally distributed with 0 mean. Okay, so this one is confusing to me because you do the QQ plot and the residuals are linear. But you do the plot of x comma residuals and you don't want any kind of pattern. So I'm going to guess you're not wanting a pattern. The residuals look normally distributed with 0 mean. I mean, they're all over the place.
Yeah. So, I mean, I did D because I don't really like any of the answers, but D's, or, I mean, I guess residuals look normally distributed, seem like the most.
Yeah. Yeah, that it is, because the only other possibility, if what I were thinking of were true, it would say that you would see a linear pattern, and none of those, that's not even a possibility, so the only other possibility is that, yeah. Okay, compute the residuals for math efficacy. Data using software. Use the confidence data, the explanatory variable, and the score data as a response variable. Okay, let's see. Oh my gosh, can I even get rid of this? Alright, so we've got to go get that. Okay, so what was it, math efficacy?
Yeah.
Okay.
So I was asking.
And which one do they want the x value to be? I guess I should check. So which one did they say they want the explanatory value to be?
The explanatory is the confidence. So confidence goes first and then score.
Okay. Oh, right. We've done this so many times. Okay.
Yeah.
Sorry, this is going to take me a second. I have to clear out all the stuff that I have. And
No, that's fine. Let's see, I guess.
Okay, I think I've got the information plotted now, so compute the residuals. Use the confidence data as the explanatory variable and the score data is essentially what statement best describes the residuals. All right, let's see. Does it tell us, I wonder?
Yeah, see, I'm confused on how to find exactly what they're asking for, because same if they're between -40 and 25, how do we even find that? Just look at the list of residuals?
Yeah, I think that's what we're going to do. It would be nice if they gave us an interval, but I don't think that they do. So, like,
Yeah.
I mean, we could probably do some math to, like, have them do it in ascending order, but I don't know. At the lowest I see is, like, -29. What are the answers here? Residuals are all negative. The residuals form a linear pattern. Okay, well, we don't want the residuals to form a linear pattern. They're not all negative, so they've got to be between -40 and 25, right?
Yeah, well, I did see a -38.
Okay.
So, and then the
They're
other,
positive values, so if they're not all negative.
is there any above 25 in here?
And it is linear. We already discussed this one last time, Manny, so it can't form, the residuals can't form a linear pattern, or it wouldn't be linear. So it's got to be the -40 and 25.
Yeah, when I did the residual plot, and they're kind of, I don't know, they're not really linear. They're kind of all over the place.
Yeah. Based on the QQ plot for these residuals, what can you say about these residuals? The residuals are fairly normal.
So the highest I see is 19, so unless I'm missing one, I think they would be between those two numbers.
Okay. All right, well, let's put the residuals just for giggles, even though I think we know what we're going to get, into QQ plot.
Okay.
Because I need to remind myself how to put them in ascending order anyway. I forget.
Should be on the data tab and then sort.
All right, I may need your help with data, where the data tab is, but okay. Hold on, let me get there before I ask the question. All right, I've got them in there. So data, is that on my actual sheet, or is that up in the left-hand corner?
I
okay.
don't know, you have the different Excel. Did you find it?
Well, no, I downloaded the Excel from BYU now. So,
Okay.
So that data, do I go to AZ sort or filter or what?
You push A to Z down.
I do?
That'll sort small
Okay,
stuff.
for some reason it's writing reference number again instead of actually writing the...
It's because you gotta, when you copy it or when you paste it, you gotta do paste to value. I kept doing that because it's trying to paste the formula.
Oh, where do I do that?
So right click and then it'll give you some paste options.
So it says paste and then it says paste special. Do I want paste special?
Yeah, it's like paste and then there'll be kind of pictures of clipboards.
It doesn't say that. Oh, okay. I want values, right?
Yeah.
The values. Okay. Then I'm on data, and you're saying push A to Z? Oh, crap. Let me see if that will change. Okay, there we go. Okay, yeah. Okay, so you can see in the QQ plot follows a pretty linear distribution. So I think we say the residuals are fairly normal, right?
Yeah. In a line.
Okay, use software to create a scatter plot of the given the scatter plot, residual plot, and the QQ plot. What's the difference between the scatter plot and the residual? Oh, the original scatter plot. Okay. Should five assumptions that linear are satisfied by this data. Check all that apply. Okay. So it'll be 1, 2, and 3. So let's see what they give us. There's a linear relationship between x and y. Yes. The residuals are normally distributed. Yes.
Yes.
The variance of the error term is constant for all values of x. Yes. The x values are measured without error. We don't know. The observations are independent. We don't know from that. So the first 3, right?
Makes sense to me, yeah.
Okay. What is B1, the estimate for the slope? I have, let's see, what am I on? Am I on the right one? Okay. We've got so many things out. 12.695?
That's what I put.
Okay.
Hopefully it's right.
What is the confidence interval for B1? 10.674 to 14.715?
It doesn't really give that. It gives the
Oh,
first
the first one's the closest, right?
which kind of makes me wonder about the slope. Because if you're confident,
Are we off by just a little?
that's what I was thinking, yeah. I don't know why. I don't know how. But
Annie, do you have this exact amount for the confidence interval for B1, or do you have what we have?
They're talking to you, Annie.
Did she leave us?
must have gone somewhere.
All
Don't know.
right, let's keep going, and we'll ask in a minute.
So about projecting the null.
Based on the evidence using level of significance 0.05, what decision would you make regarding the hypothesis test for B1? So we're going to say, let's look at the p-value here. Oh, yeah. Reject the null, right?
Pretty small.
Because p-value is less than alpha.
Mm-hmm. And then, because it's so small, we say there's sufficient evidence to conclude that the slope of the regression line is 0.
It's not 0, right?
Oh, it's not 0? Is that right?
Yeah, because our
Okay.
null is that it's 0,
Yeah.
right?
Yeah. I was thinking, yeah, it's not 0, right?
Okay. All right, let's see.
Or get to. What happens when you reject the null?
Now we're going to look at Eusterian
Crocodiles.
crocodiles.
Hey, sorry. I had to go help my son. Did you go ahead and go on with it?
We did.
Okay.
So, we were. I'm gonna ask you though. Let's ask that question, Drew. On your confidence interval for B1, number 10, what do you have?
The slope.
Number 10.
Yeah, the confidence interval for the slope. What do you have on yours?
Should have access to math FSC. Oh, I've got
No,
way
not
too
math. Oh yeah, sorry, math self-efficacy. Yes.
For the B1 slope, I have 12.695.
Yes, that's what we have too. Okay, but the confidence interval, and when you look at the confidence interval,
Oh.
what do you have for the confidence interval for the slope?
10.674 and 14.715.
Okay, that's what we have too. And it's not one of the options. We got close. A is really close, right? But it makes us a little nervous that our rounding may be off. So we'll see.
Yeah. That's weird. I mean, even if you extend the decimals, there's no way it's going to end up being that.
Right.
Huh.
So we're going to go with A on 10. We're just worried that, and we think that's probably right, but number 9 may be off by a fraction of a decimal. So, but
Okay.
we'll try and fight it. I mean, all 3 of us get it. Come on, it's got to be right, right?
Okay, and then number 7, they're fairly normal, right?
Yeah, residuals are fairly normal. And then number 8, we said A, B, and C. There's a linear relationship between x and y. Residuals are normally distributed, and the variance of the error term is constant for all values of x.
Okay. Okay. And then slope is 12.695. Okay. Okay, and then number 11.
The p-value is so small, we have to reject the null
Oh,
hypothesis.
yeah. Geez, it's huge, way small. Okay. Okay, and 12. It means there's Is it that there's insufficient evidence to conclude the slope is not 0?
There is sufficient evidence, because whenever you reject the null, you usually say there's sufficient evidence.
Yeah.
There's
Okay.
sufficient to conclude that the slope of the regression line is not 0.
Okay.
And then for number 13, the dependent variable for the Estarian, whatever how you pronounce that, is body length.
Yeah.
Right? And then since the 99% confidence interval for these data is this, what can you say about B sub 1? So the interval does not contain 0. There is sufficient evidence to conclude that B sub 1 is not equal to 0. You could probably say that. There's a 99% chance we know that you'd never say that. There's insufficient evidence to reject the null hypothesis. Let's see. That seems unlikely since the p-value is tiny.
Mm-hmm.
So I'm going to go with A. What do you guys think?
Sounds about right.
Okay. All right.
That's what I would say is A.
Okay, well, let's just go over our answers. Number 3, everybody have C, H of O, B1 equals 0, H of A, B1 does not equal 0.
Mm-hmm.
Okay, number 4, a residual is the difference between the observed value of y and the value predicted by the regression line.
Yeah.
Okay. Number 5, the residuals look normally distributed with 0 mean. Feel pretty confident because the others don't look great. Number 6, residuals are between -40 and 25. Number 7, based on the QQ plot, the residuals are fairly normal.
Mm-hmm.
Number 8, A, B, and C. Number 9, 12.695. Number 10, first one. Number 11, reject the null hypothesis because the p-value is less than alpha.
Mm-hmm.
Number 12, there is sufficient evidence to conclude that the slope of the regression line is not 0. Number 13, body length. And number 14, since the confidence interval does not contain 0, there is sufficient evidence to conclude that B sub 1 is not equal to 0.
Yeah.
Okay. We got it.
Awesome.
Okay, yeah, so all we have is the review and that group project.
It's kind of exciting.
Anybody going on with statistics?
No way.
No way. I'm thinking about it, actually. And I cannot, oh, here we are. I was going to say, I can't find our video. Here it is. Okay. No way. This is your last one. You don't have to take it anymore.
I don't know. I love math. I love numbers, but this class is just I don't know. It's a little too much for my brain.
Well, all right. I think you've done great. Nice. I think it's been a great team, so thanks,
Oh
guys.
yeah, definitely.
Um, okay, so we'll work on the review and meet up Tuesday. I'll try and get that information, like I said to you guys, tomorrow. If you'll just look over it and let me know if you want me to make any changes. And Drew, if you'll send me that, what you're sending in, so that I can just kind of make sure it all flows, then we'll go from there. Who did we decide? Annie, are you doing the PowerPoint?
I thought we were all kind of doing the PowerPoint, and then me and Bernice were supposed to split up the make inference and take action. I don't remember which one of us was doing which, but it should be on the design the study.
I do have that here.
Is that what you have written down?
Yep, I got it all right here.
Okay, I don't think the make inference and design the study is going to be real hard because, or I'm sorry, make inference and take action is going to be real hard because, basically it's just you say, okay, well, based on this, we reject the null hypothesis or we don't.
Yeah.
And then we're going to have to be creative about taking action. I mean, there's really not a lot of action you would take based on our information, but.
So if we want to do that, because they do combine make inference and take action as the assignment, so I'd be willing to do.
One person could cover that pretty easily.
And then,
of course, we'll all help with the PowerPoint, but somebody needs to kind of take the PowerPoint presentation and be the one to put the PowerPoint presentation together. And really that will be based off of all of our stuff, right? That's another reason, Drew, to send it out, is because the PowerPoint presentation needs to include everything that we've done so far.
I can do the PowerPoint.
You feel comfortable with PowerPoint? That'd be great.
Yeah, and the make inference take action, Bernice could probably do. I mean, it's pretty much a template that you fill out, just like the other ones. Right.
Okay. Now, is that it? Is that I don't have it in front of me right now. Is there anything else besides those that we do?
We've done collect. Have we turned in collect the data?
I haven't turned it in. I wanted to get your input, and then I will turn it in.
And then describe the data as well.
I'm doing that one.
Okay, perfect. Then that's it.
Okay. So we'll have Bernice do those two, and then we'll have, And so, and Annie, honestly, I think you're really just kind of putting together what we've done.
Yeah.
And so then, if you want more stuff from us, just tell us, Drew especially, he can do some more. And then, and we'll do whatever you tell us, but if you'll be the one to just kind of put it together, that'd be great.
Absolutely. And if I open up the PowerPoint, it kind of says there should be a slide for design the study, a slide for collect the data, a slide for describe. So yeah, pretty much exactly what you said, just all the stuff that we've already done.
Okay, perfect. All right, so Drew, make it look good when you send it out to us.
The original design, the study.
Yeah.
Well,
it's gotta look good.
I just wanted to add, just want to add a little addendum to, since you changed the hypothesis, right? You're going to use the chi-squared, weren't you?
Yeah. Yes.
So how would that be worded out exactly? Because I need to update what it was from before.
How would the null hypothesis be worded? Is that what you're asking? Or how would so the null hypothesis is going to say, so if you look at my collect the data, I pretty much say it. Mm-hmm. So it's among our Facebook friends, because that kind of helps us with our, population. Among our Facebook friends, are gender and season preference independent. And so our null hypothesis would be that among our Facebook friends, gender and season preference are independent, and our alternative hypothesis would be that among our Facebook friends, gender and season preference are not independent. I would include among our Facebook friends. That's up to you guys. I mean, it doesn't matter, but just so that we're specifically identifying who our population is.
Yeah.
Because I mean, honestly, it's a biased sample, but it would have been pretty hard to make it an unbiased sample.
to reduce it as much as you can now.
You want to get rid of some of them?
No, just by the steps we've been taking, we've been reducing bias. is what
Yeah.
I'm
Yeah. So.
saying. Okay.
All right. So we're good.
I think so. Yeah.
Mm-hmm.
All right. Ready for Tuesday. All right. Have fun, you guys. We'll see you then.
Okay, sounds good.
Thank you. All right. Have a good night.